So today we're going to be talking about AWS cloud connectivity options for campuses, meaning large campus environments, branch offices, and data centers. My name's Jay Radford. I have a background with Juniper Networks, primarily on the firewall product line, going all the way back to the NetScreen days, if anyone remembers those. Now Juniper's on the third generation of firewalls. They've just released these SRX 300 line and refreshed the product line again with even more horsepower and more performance, so you get even more bang for your buck. Tess here also works on the Juniper on the networking side, and we have Colin who's going to be joining us shortly, who's our AWS expert. We're both solutions architects with Blue Chip Tech, and we have helped a lot of customers connect their both their campuses and their data centers to the cloud using Juniper technology. So Jason just gave us a short introduction. Thank you, Jason. First we'll start with a VPC overview. Why do I even need connectivity to the VPC? We'll talk about the options like VPN versus Direct Connect, and we'll kind of compare and contrast those options. We'll go through a couple of case studies which are pretty much mirror images of the customers that we've helped them connect to the cloud and solve their problems. Typically it's branch offices, campuses connecting into the cloud. How does my existing data center connect to the cloud? And what are the options for a hybrid data center available? And then we'll get into why we feel Juniper SRX is the right product of choice for both VPN and Direct Connect to the cloud. With extensive routing support on JunOS, it's the same BGP that service providers are using every day. It's the same BGP daemon that runs on that box. It's adopted worldwide, and Juniper has a very industry-leading stance in routing. We'll briefly touch on other Juniper cloud solutions that are coming into the AWS marketplace. And we'll take a little break, and those who wish, we can go through a lab today. We have a virtual SRX for all of you guys to log into and play with. We have VPC instances set up for 10 people, so we can have 10 people connect their virtual SRXs to the cloud. And then we can you do bidirectional data flow. You can SSH. There's an Ubuntu system in the cloud waiting for you to connect to once your VPN's established. So as it stands, a lot of you guys have an AWS infrastructure already, or you're piloting one. And inside that, you may have one or more VPCs or virtual private clouds. These may be hosting file systems or EC2 instances or Redshift, right? And then you have your private corporate campus data resources, like your branch offices, all your sales offices, facilities, headquarters, and legacy data centers. And you need a way to connect them into the cloud, right? Sometimes you just need access to the front end public side of the services. Right? Sometimes you need full access into your VPC and a bidirectional data flow where connectivity can both go from your enterprise into the cloud and initiate in the other direction, so that the cloud systems can connect into certain systems within your enterprise or data center. So we'll cover the options for those today. Well, first off, why do I even need a VPN connectivity? So a local IPsec tunnel allows you to get into your VPC backend. When I say the backend, I mean the private IPs within your VPC domain, right? Whether you just use this for initial management, backend management of your VPCs through SSH or RDP or whatever technology you're using, or whether you need full, bidirectional communications back to your enterprise, right? An IPsec VPN is pretty much the fastest and easiest way to get going with AWS. But in fact, the VPN is pretty much technically required because we're routing a private subnet over the internet to another private subnet. So hence we use IPsec for the encapsulation. Right. It also allows us to secure this communication and authenticate the traffic back into your internal networks. So the VPN option is essentially the easiest to set up, and that's what we'll be rolling through today. Direct Connect is another option. If you have a qualifying data center, which is basically an Equinix data center, you can order a direct connection, 1 gig or 10 gig. Essentially, it's a point-to-point circuit between the Amazon cage and your equipment. Of course, the point-to-point circuit has to terminate on a router that runs BGP, and these Juniper SRXs do that just fine. For higher scale environments, there's a Juniper MX series, which takes multiple full routing tables and has very fast convergence time. It's a purpose-built router, but same features are available on the SRX as well on a smaller scale environment. But essentially, with Direct Connect, it's Not as easy to set up because there's more of a provisioning process, because you actually have to provision this point-to-point circuit. You have to connect it to your CPE equipment, right? You get 1 or 10 gig ports. It's nice because there's dedicated bandwidth, and it works as a VLAN trunk, so you can actually map certain VLANs to certain VPCs. If you have multiple VPCs, you can use that trunk link to kind of directly connect those. Of course, with the direct connect, it gives you the direct connection to both AWS and your VPC, whereas with the VPN option, you just get into your VPC, so you have a faster access through your direct connect to the Amazon services, the public-facing services, rather than going out through the web to your Amazon console to manage things. Amazon's been updating which data center locations this is available in, so there's an FAQ listed here, and this is the current list of data centers. SV3 that are around the corner, SV1 is available. But it's essentially, the current limitation is you can only get a direct connect in a data center that Amazon has a premise in. So those are really the two options. I mean, besides the point-to-point circuit I mentioned, it runs a trunk, so you can have multiple VLANs essentially spanning this to go to different VPCs. And then the routers themselves, of course, can do things like QoS and rate limiting and security enforcement across all those VPC connections. And that would be the router that you control. So you get to enforce a security policy there with your equipment. As you go through the Amazon Web UI, this is just what it kind of looks like when you get started with Direct Connect. You have to select a location, make sure it's a supported location, order your connection. Once the circuit gets provisioned, you can connect your network and then configure these virtual interfaces, one for each VPC. Right, and I put the FAQ there so you can get the list of updated data centers where Direct Connect's available. So kind of comparing and contrasting the two options, right? The VPC IPsec VPNs are very easy to set up and provision, right? We can get one of those running in a few minutes here. And it's easy to VIP and reconfigure a VPN endpoint. Let's say, your office moved from Mountain View to Sunnyvale, and now you have a new public IP address, and all you just kind of log into Amazon, you put in the new public IP, and it'll spit you out a new config file, right? Whereas with the Direct Connect, of course, that's a whole circuit reprovisioning thing that may take weeks. Kind of a neutral pro or con. You can only do 10 VPNs per VPC with what Amazon says 4 gig maximum theoretical, right? Obviously, if we're in an office like this and we've got a few people sharing the bandwidth, right, then your available bandwidth is going to be impacted. So there's some techniques we can use on the Juniper SRX to kind of prioritize traffic going across that VPN connection, or discarding other traffic to make more available bandwidth. Bottom line is your performance is still dependent on your available ISP bandwidth, your first hop up, so to say, because these ride over the internet. Direct Connect, of course, the downside is it's only available from those supported locations. If you do have a presence in one of those locations, you can connect your Direct Connect there, and then through your enterprise WAN, you can route to it from there. Right? So if you have one data center in Equinix, you have a point-to-point link to your headquarters to Equinix, you can utilize that connection and route the traffic across the Direct Connect link using your existing infrastructure. Of course, it's more complex to provision. But the plus side is you get dedicated bandwidth for your AWS backend, and you can get a 10 gig port with a Direct Connect, and you host your file systems over in Amazon and get plenty acceptable performance. Right? And it supports multiple VLANs for multiple VPCs, what they call virtual interfaces. Some environments you may have a mixed scenario, like I mentioned. Here's your AWS region with your VPC. You may have a Direct Connect to a supported data center, like an SV3. Right? And then as I mentioned, that data center may have a connection to your headquarters or even your other branch offices. So it kind of, you deploy the CPE in the data center with a Direct Connect, and then you use routing to advertise routes across the cloud here. And typically it'll be OSPF within the enterprise, advertised via BGP across to Amazon. And that's where these Juniper devices will shine, because they'll do OSPF and BGP, and there's the export policies are very configurable and fine-tuned, and then you don't need to buy any licenses to do those on the SRX because it's included. So here we have a scenario where yes, the corporate headquarters is connected to the data center, and that uses the Direct Connect to the data center at 10 gig, and then they have a couple of branch offices connecting over the internet using the VPN VPC. Of course, these are more sensitive to latency and packet loss because they're going over the internet. But for, as we find for a lot of production deployments, obviously you would be testing your performance first, and you can find out if that's adequate for your needs, depending on your available bandwidth. And if you just need to get something up and running like tomorrow, VPN's your best option. Great, so here's a little more of the technicalities of it all. So you have servers or file systems in your EC2 instances. Here we have 2 instances just for show. And then you have your private network, your customer private LAN or WAN, right? You may have, sorry, the animation kind of blacked out, but you got wired users, you got wireless users of all types. You have servers, you may have security equipment, point of sale equipment, IP phones, anything that connects to the LAN, right? Now you have your Juniper firewall as the edge device there, connecting to the ISP router, and Amazon will actually build you 2 tunnels for redundancy, and they will use BGP to kind of select the best path for your traffic, which also works great on the Juniper because the BGP ties right into the VPN features. So if the VPN monitor detects a failure, the BGP route will deactivate, and you can fail over to the other tunnel within 5 seconds or so, depending on how you set your timers. You can have very fast convergence time. So technically, yes, you can connect your private network into your cloud this way. And this is just an example of one location. All the policy enforcement into the AWS cloud is done on the Juniper SRX. So you maintain security policies here that control which traffic is allowed to and from your VPC instance. And of course, that's because it's a firewall. That's what it does, policy enforcement. And of course, all the next-gen firewall features like application identification, app QoS, app firewall tracking, they're all available on these connections as well. Of course, you may wish to connect multiple offices to the cloud, right? You've got New York, Los Angeles, and Miami, right? Each location you have a public IP address, probably already a firewall, and you essentially just terminate multiple VPC gateways into the, and of course each network here would have a different private IP address, and that would all be advertised into the VPC via BGP, right? And as it stands, they support 10 locations per VPC. So,
is that 10 locations with dual tunnels?
10 locations with dual tunnel.
And that's actually a soft limit, so if you have a use case where you need more, yeah, you can call them up.
Okay.
And of course, it builds the dual tunnels to each location. Primarily, that's to facilitate failover. If Amazon's doing maintenance on one of their environments, the tunnel may go down, but you have your second tunnel so that they can provide you better availability. But it also helps, if there's some outage across the internet or a certain gateway gets overwhelmed, the traffic can be forced in other directions. And we could talk about mixing these solutions for the ultimate high nines data center. A lot of this in the examples I'll use, some of our customers have migrated their VoIP and IP telephony, or Skype, it's Skype now, solutions, over to the data center, but they still keep a private data centers where they have all their, maybe their DS3 circuits or their SIP trunks, or the actual media gateways themselves. Other things we're seeing is, legacy operating systems and systems that just can't be moved to the cloud. They still need to keep that private data center for such purposes. And as long as these systems run IP, they can talk to the AWS systems back and forth. So we see a lot of reasons why customers aren't able to move 100% to the cloud. Although that's what the higher ups plan may be, to move everything to the cloud. A lot of the times it doesn't make sense to move your media gateways, anything that has all the point-to-point connections, right, and legacy type services that you're just not ready to move yet. And it also allows you to have kind of a staged migration approach where you get your direct connector or VPNs up, you can start moving systems to the cloud like one by one, right, rather than have a hard cut over of everything. Amazon recommends this for the ultimate availability, where you have redundant direct connections to your data center, and then you have VPN for backup. So it's in this scenario, there's a VPN gateway and 2 direct connections. Okay, now I'm going to give you a brief overview of the Juniper SRX and why we believe it provides the most cost-effective security for your AWS connectivity. You can see up here we brought in a new SRX 300 series. These are the latest generation of the platform you may be familiar with. Much more horsepower than before. Of course, they're all multi-core, and they actually run a virtualized version of GNOS. So when you do a software update or something like that, you're really just running a new version of the virtual GNOS, and it just switches over real quickly. It's called in-service upgrade. Of course, Juniper SRX provides a low-cost, high-performance security platform, which provides you a very efficient entry point into your VPC. The advanced routing and security features, which are on every GNOS operating system, the same BGP that service providers are running, so it provides you efficient routing and security, as well as switching features. All Juniper platforms offer high availability features. Can give you up to 5 nines availability for production grade connectivity. And of course, there's a wide range of different hardware models, including the virtual SRX, which also runs GNOS. What we see here inside the SRX platform, which is built on GNOS industry standard routing, also has switching features, as well as firewall and VPN functionality. The next-gen firewall set, referred to as UTM, includes intrusion prevention, antivirus, anti-spam, and web filtering. This is all on a single device to manage, which provides comprehensive security. And it's easy to activate additional layers. If you'd like to subscribe to the antivirus features, this sold as a yearly subscription. And we see how the Juniper SRX would connect into your Amazon VPC here. We've broken this down. Obviously, the SRX would connect to your local ISP, and in the Amazon deployment, it will deploy 2 tunnels, a primary tunnel to your virtual gateway 1, and a backup tunnel, secondary. Now, these tunnels terminate inside the SRX on what we call tunnel interfaces, or STO interfaces. And here you can see these are deployed in a zone called the VPN zone. This also runs the BGP to handle the routing to and from the Amazon cloud. Also inside the SRX, you have other types of interfaces, like redundant Ethernet interfaces, other VPN interfaces, or WAN interfaces. In a multi-ISP setup, you may have 4 tunnels built, where 1 tunnel becomes a primary, and 2 tunnels on each ISP router are deployed, so that even in the event of an ISP failure at your local office, connectivity to Amazon is maintained. Here we see in this fully redundant scenario, 4 tunnels are built, each to their own tunnel interface, within the VPN zone, all running BGP to exchange routing information to the cloud. Thank you for coming, and we hope you enjoy the training.